Good afternoon, everyone, and this is lecture number 8 in thermodynamics. I think we are dealing with specific heats of gases, and in the previous class we had seen what we had seen that there are two types of specific heat for gases. One is known as specific heat at a constant volume, and the other one is known as specific heat at constant pressure. The specific heat at constant volume or specific heat at constant pressure, it basically gives us the amount of heat required to raise the temperature of 1 mole or 1 gram of a substance by 1 degree Celsius. Yes or no? No, yes. We'd also seen the Maxwell's law of equipartition of energy, where we had seen that the total internal energy of the gas can be written as F by 2 NKT, where N is the number of molecules and K is the Boltzmann constant, or F by 2 nRT, where N is the number of moles and R is the universal gas constant. We had seen the Mayer's formula for an ideal gas, Cp by Cv is equal to gamma. We had seen the relation between gamma and F, yes or no? It also
Yes,
created this revolutionary table where we had seen what? How all the things related, transitional kinetic energy, rotational kinetic energy. Here we have not included vibrational kinetic energy. If it is vibrating in one dimension, two terms will get added up. Yes or no? Cp and Cv of the mixture was the next topic in line, and we had seen how to find out the Cp and Cv of a mixture. Very important points. Questions have come on this. Then we had seen the most important aspect: state variables that define the state of the gas, tells us what the gas can do, in what state the gas is. And internal energy is one of the state variables which does not depend on path. It is like conservative force. Change in energy for a conservative force does not depend on path, it only depends on initial and final positions. Do we understand this?
yes, sir.
Then there is a question coming up. Two moles of an ideal diatomic gas undergoes a process where its temperature increases by 50 degrees Celsius. Find delta Q and delta U. If do you understand the meaning of delta Q and delta U? Do you understand the meaning of delta Q and delta U?
Yes, sir.
Delta Q is the amount of heat given at delta U is the change in internal energy. Two processes are given, one is at constant volume and the other one is at constant pressure, and I'll give you 2 minutes to give me the answer for this one. And tell me the answer, sir.
Sir, delta Q for constant volume is 25 R.
Delta Q at constant volume is NCV into delta T. Yes or no?
Yes, sir.
Number of moles is 2. CV for a diatomic gas. What is CV for a diatomic gas? 5
2
by
by
2
5, 5 by 2 R
5 by 2 R into change
into
in
50.
temperature is 50. That is the answer for heat given at constant volume. What is the change in internal energy? That is also same. Then that is also same. Yes or no?
Yes, sir.
What is the heat given at constant pressure? It will become N Cp delta T.
Delta
Yes or
T.
no?
Yes, sir.
2 into 7 by 2 R into change in temperature is 50 degrees Celsius. What about the delta U in this process? What about delta U in this process? Remember, whatever be the process, change in internal energy is always NCV delta T. Do we understand this, or this has gone above our head saying bye bye? Do we understand this? That is the
Yes,
main
sir.
point of this chapter. I'll give you 1 minute to note it down. Question may require some calculations. I hope you will be able to do it. Shall I help you out? I'll give you 2 minutes more. Anyone got any answer?
No, sir.
No, sir. Is it such a tough question? And my students are not able to do this. Shall I do it now?
Yes, sir.
Very sad. What's so tough in this question? What's so tough in this question? Tell me what is so tough? What is so tough? Do you remember the formula of speed of sound? Speed of sound is root over gamma p by rho. Standard pressure is given, so you know the value of p. You know the value of rho. Value of v is already given to you. From here you will get gamma. You just have to calculate it. The value of gamma that is coming is 1.41. Once you know the value of gamma, gamma is 1 plus 2 by f. I've already given you the relation. You would have found out the degrees of freedom. The degrees of freedom is 5. What was so difficult in this question? Tell me. Tell me which part was difficult. Tell me fast. Which part of this question was difficult that you could not do? Tell me. Which part of this question was difficult? Which formula you did not remember? Tell me. Calculation part, formula part, which part? No answers. No answer is a very bad answer. The worst answer is a no answer. Anyways, I leave it to you. I'll give you 2 minutes to note it down. The next point that we are going to see, and I have recently seen some questions coming from this topic, is known as mean free path. Mean free path. Now, what do you mean by this mean free path? You must understand that if you're talking about these gas molecules, and there are a lot of them in a very small quantity of gas also, these gas molecules are moving randomly. When they are moving randomly, they are colliding with each other very frequently. Now, the distance that they travel between two collisions is known as the free path. The average of all these free paths, the average distance traveled by a gas molecule between any two successive collisions is known as mean free path. And that is a term that has come in the exam on a consistent basis in the past 2-3 years. So it becomes prudent for us to see the formulae for this mean free path. And this mean free path is the distance traveled, average distance traveled by a molecule, by a gas molecule, the average of the distance traveled between two successive collisions. That is your mean free path of a gas molecule. If lambda 1, lambda 2, lambda 3, and so on are the distance, the free paths for individual particles, the average of these paths taken is known as the mean free path. Do we understand this? Yes or no? Do we understand this?
Yes, sir.
Pakka, sir?
Yes, sir.
Okay. Now, I'll give you time to note it down. Chalo, you note it down now. Let me know once you are done. Now, how do I find this mean free path? That is out of our course, but we must remember on what all factors this mean free path depend on, and that is the part which is important. On what all factors this mean free path depends on. This mean free path is represented by the letter lambda. It's represented by the letter lambda, and this is the main formula for this mean free path. On what all factors this mean free path depends on, and these are the only two factors on which this mean free path depend on. What are the two factors? You can see these two factors here. The first factor is the diameter of the particle, diameter of the molecule. If the diameter is large, then the mean free path obviously will be small. It is inversely proportional to diameter square. That is what you have to remember. Diameter square is inversely proportional, and at the same time, it is also inversely proportional to the number of molecules in a unit volume. Obviously, if there are more molecules in a unit volume, there will be more collisions, and therefore your mean free path will decrease. Do we understand this? That is the only thing that you have to understand here.
Yes, sir.
If you just remember this yellow equation, all the questions that has ever come in your GE will be solved. Now I can write various variations of the same question. I can write the various variations of the same. See this n. See this n. The gentleman n. This n is the number of molecules. Here they've written it as number of molecules per unit volume. Number of molecules per unit volume. Now, if you remember this gas equation, PV is equal to, let me write it as N naught KT. I'm just changing it to N naught. This N naught was the total number of molecules. So this N naught by V becomes the number of molecules per unit volume. Yes or no? No or yes?
Yes, sir.
So that becomes your legendary P by KT, where K is your Boltzmann constant, and then I can write this legendary formula, this legendary formula, this legendary formula, this legendary formula, this legendary formula. Lambda is 1 by or root 2 kt by pi d square p. This is purely a revolutionary formula. And you must understand that this formula has not appeared. It just is derived from equation number 1. Do we understand this? Yes or no? No or yes? Note down these formula aram se. There is one more variation of this. Again, it just comes from elimination. This is the variation. Oops. Chalo, this is the variation that I'm talking about. M is the mass of one molecule. So you can substitute this formula in a different way and you can get this answer. You can get this revolutionary form as well. One more revolutionary form on which I have seen a couple of questions. Lambda is equal to V average multiplied by T, where this T is the time interval between collisions. V average is the average speed. V average is the average speed and T is the time interval between collisions. T is the time interval between two collisions. Very, very useful formula. I'll give you 2 minutes to note down these important formulae because the question can come from here. I always tell you what is important that you have to write. I also tell you what is not important and you just have to understand and write it in very short. This is you write in elaborate form and you write it without looking at the board. So while you are writing, you are able to memorize it. Look at the board once, look at all the formulae, keep them in mind, and then write without looking up. That is how I used to remember things. If you just keep on doing this in the examination hall, you will be doing this, reading the question, then again reading the question, doing nothing, just reading the question and like this. Your neck will just keep on doing this. I'll give you 2 minutes to do this. Well, the more the number of questions that we are going to do, the better we are going to become. So here are a couple of questions from here. Remember, it's very difficult to get questions on mean free path because the number of questions are very, very limited. That is a good thing. That is also a bad thing. Good thing because the number of questions are very limited. The same questions are going to get repeated more often or not. If the mean free path of atoms is doubled, then the pressure of the gas will become. Yes. Mean free path is doubled. What will happen to the pressure? Option 1, 2, 3, 4. Which one?
B, sir.
B, sir. Option 2, sir. Lambda is going to write the formula again so that this formula becomes a part of our system. Lambda is equal to kt by root over 2 times pi d square p. Everything else remaining constant. Lambda is increased 2 times, the pressure should become half because it is inversely proportional to the pressure. Assuming that the temperature remains constant. Do we understand this?
Yes, sir.
The mean free path of nitrogen molecules at a pressure of 1 atmosphere and 0 degrees Celsius is itna. If the number of densities, if the number of density, the density of the molecules is 2.7 into 10 to the power 25 per meter cube. What is the molecular diameter? I'll give you a minute. Might require calculation. I just need an approximate answer. So how are we supposed to do this? This is a straightforward answer, right? Mean free path, that means lambda is given to you, 0 degrees Celsius means temperature is given to you, pressure is given to you, number of molecules per unit volume is given to you. You can straight away apply the formula. Which formula am I talking about? Lambda is equal to 1 by root over 2 pi d square into n. You don't have to use even pressure or temperature because this pressure and temperature is just given as an additional data. Number of molecules per meter cube is given to you. you can straight away use this data. Do we understand this? Yes
Yes,
or
sir.
no? Yes or no?
Yes.
Everyone has understood this? Shall I move ahead?
Yes, sir.
This is the next question, sir. The question which came in your JE. A 25 into 10 raised to the power minus 3 meter cube volume cylinder is filled with 1 mole of oxygen molecules at room temperature. The molecular diameter is itna root mean square. The molecular diameter is 0.3 nanometer and the RMS speed is 200 meter per second. What is the average collision rate? How many collisions are happening per second? I'll give you 2 minutes to think about this. What you can do, instead of solving the question, you can give the answer in algebraic form, alphanumeric form. You can call the total volume as V. You know that the Avogadro number, in 1 mole, Avogadro number of molecules are there. So you can call it as N naught. You can call the temperature as T. You can call the diameter as D. And you can call this as VRMS. So you can give your answer in terms of these quantities. I would be happy to welcome you with that answer. 2 minutes start now. My intention is not to get you into complex calculations. Everything is given to you, my dear friend. Whew. From where should I start? Okay, I'll start from here. Solution. Your lambda is equal to V average multiplied by tau or T. Time between two collisions. Time interval between two collisions. Yes or no? Yes or no?
Yes, sir.
You have to find out the average number of collision per second. So that is the inverse of tau. So you have to find 1 by tau, and 1 by tau is V average divided by lambda, and that is the answer, my dear friend, because everything else is now known. V average, VRMS is given to you. Yes or no? You can find out V average from VRMS. Who is going to tell me the relation between V average and VRMS? What is V average in terms of VRMS? Huh? We don't know, sir. This is the first time we are hearing RMS and average speed. How do we know, sir? We are not all knowing, sir. We don't know everything, sir. What is V average? We don't know. What is VRMS? We don't know. Huh? V average, VRMS are just velocities. Yes. Root over 8 by 3 pi into VRMS. Told you to remember these relations. Writing everything does not help. Remembering things help. So I know the value of VRMS. Lambda. I've already given you the revolutionary formula of lambda. Revolutionary formula of lambda. Here, my dear friend, is the revolutionary formula of lambda. You just put that revolutionary formula of lambda. Everything else is given to you. Chalo hai. Everything else is given to you. you can get the value of what is required. The time between the number of collisions per second. You just have to put these two formulas together and you are there with your answer. Lambda is kt by root over 2 pi d square into p. So your number of collisions per second 1 by tau becomes root over 8 by 3 pi into V RMS divided by KT divided by root 2 pi d square p. I would suggest that you leave such questions if they come, even though you know how to do them, because there are a lot of calculations that you have to do here, and there are chances that you are going to make mistakes in those calculations, even though you know how to do it. So if such a question comes, just say bye bye and move ahead in life, because instead of getting +4, you might end up with -5, and you might lose a lot of time as well. Both things are dangerous for you. Both things are dangerous for you. So I would suggest, otherwise, I would have been in your place. I would not have attempted this question. What about this one? What about this one? Probably I would have attempted this one. An ideal gas is enclosed in a cylinder at a pressure of 2 atmosphere and temperature 500 K. The mean time between two successive collision is 6 into 10 raised to the power minus 8 seconds. Time between collisions. If the pressure is doubled and temperature is increased to 500 Kelvin, so this is the ratio wala question. And I'll give you 2 minutes to show your talents. Students are like cash vouchers. Sometimes the cash voucher may not work. It's not because something wrong with the cash voucher, something wrong with the person who has filled up that cash voucher. So you have time to redeem yourself and get your value back. 2 minutes you have. That is correct. It's option A. Redemption, whether it was a guess or not. But that is correct, my dear friends. How are you supposed to do this? Remember simple things in life. Lambda is 1 by root over 2 pi d square p. The only thing you have to remember, it is inversely proportional to d square. Now the gas molecules ka diameter is not going to change. So that question will not come unless and until they ask you the diameter of the gas molecules. Lambda is inversely proportional to p. You see this. Then we talk about the average velocity of gas molecules. Pi d square p into k into t. Sorry, I forgot k into t. K into t, where t is the absolute temperature. Yes or no? Is directly proportional to this. V is 8 by pi kt by m. V average. Yes or no? It is directly proportional to root over t. If you don't want to do this, tau, the time interval between collision, is lambda by V average. Yes or no? If you divide lambda by V average, it will be coming proportional to 1 root over t will get cancelled. It will come proportional to root over t by p. Yes or no? Yes or no?
Yes, sir.
That's it, sir. So tau 2 by tau 1 will be root over T2 by T1 into root over P1 by P2. Tau 2 is 300, 500. T1 is 300. So it is root over 5 by 3. Some calculations here also. Multiplied by the pressure is doubled. Why I've written root here? It's not. The root is not here. Why I've written root here? Pressure has become doubled. So this is the ratio. Tau 2 by tau 1. Tau 1 is already given. When you multiply, the answer that is given to me is this one, and I hope that it is correct. Do we understand this, or this has gone above our head saying, bye bye, I'm going, bye bye, I'm going, bye bye, I'm going? Huh? You understand this, bacha?
Yes, sir.
Pakka, sir?
Yes, sir.
Have you noted it down, fatafat?
Yes, sir.
Shall we move on to the next question, next set of questions?
Yes, sir. Sir,
Yes.
temperature is increased by 500 Kelvin, means it is 800 Kelvin now, sir.
Temperature is
Increased to, okay, sir. Sorry.
read the question carefully, beta. This is the next question coming on your screens now. For a gas, R by CV is 0.67. This gas is made up of molecules which are what? You have to remember the value of CV in various ways. Now, I've given you one way. CV is F by 2R, yes or no? And Cp is F plus 2 by 2R, yes or no? There is one more way of remembering this in terms of gamma. This is R upon gamma minus 1, and this is gamma R upon gamma minus 1. Keep it in your mind, because sometimes something may be more easy to get an answer from. Remember, JEE is all about getting answers correctly and more importantly, quickly. I'll give you 2 minutes to give me the answer for this one. It is monoatomic because R is gamma minus 1. Comparing it, we will get gamma minus 1 as 0.67. That means gamma is 1.67 and gamma for a monatomic gas is 1.67. So as I told you, if you remember things in different ways, it's a matter of time. You want to get to the answers quickly rather than late. Fatafat. Give me the answer for this one. 40 calories of heat is required to reach the temperature of 1 mole of an ideal monatomic gas from 20 to 30 at constant pressure. The amount of heat required to raise the temperature over the same interval at a constant volume is how much? How did you get 60 calories?
Sir, I have taken that delta Q equals to NCP delta T.
Yes.
Delta Q is 40.
Yes.
N is 1.
Hmm.
And delta T is 10.
So the value of Cp is
4.
4. Some unit calorie per mole per Kelvin.
Yes, sir.
From there you can find out the value of
CV.
what will be the value of Cv?
1 plus F by CP is equals to 1 plus F by 2 into something.
What something? I want the answer.
Sir, it is given monoatomic gas, no, sir.
Yes.
So
That
directly,
may be a misprint. That would be a misprint. Otherwise, the question becomes redundant. 1 mole of a gas.
yeah.
Cp is 4. How do you get the value of Cv?
Sir, 1 plus F by 2 into R is equals to 4, no, sir. Wait, CV.
JEE is a test of your speed. If you go by the longer way, you will not get more marks. Cp minus Cv is R. So Cp is 4, Cv becomes 2. So your heat given at constant volume becomes 1 into 2 into 10, and the answer is 20 calories, my dear friend. Compared to a constant pressure process, constant volume will always require less heat. If you would have known that, there was only one option which was correct. Even if you did not know it, the answer is this one. Do we understand this? Mayer's relation. Did we do it in the last class? Yes or no? That was the last question. You have noted it down, yes or no?
Yes, sir.
This is the next question. You write a lot of things, but you don't remember them. No point of writing them. That is why I have to make sure that I do each and every question, because even if I miss a single one and that same question comes, I don't have the confidence that you are going to do it. Anyways, this doing question is a confidence building measure for you and me both. I try to give it you all types of questions that have come or can come, potentially come. The specific heat of a gas, which one is correct?
A, sir.
Yes, sir. There are only two processes in this universe, Cp and Cv. It can be anything. It can be any value. It can be of any value from 0 to infinity. For any process, we can find out the specific heat of a gas. Told you that. Again, you don't remember it. Anyways. Please remember it. For gas, for different processes, the specific heat can be calculated. and there are infinite processes which are possible, and therefore infinite specific heats of a gas. This one from IIT-JEE. An ideal diatomic gas is heated at constant pressure. What fraction of the heat energy increases the internal energy? Heat energy given to a gas does two works, does two jobs. One is to change the internal energy, the other job we will see in the next chapter. This is a simple question. Can I have the answer for this one? Give you 2 minutes to do it. So what you have to find out is the ratio of heat supplied, fraction of heat supplied increases the internal energy. So you basically have to find delta U by delta Q. So you basically have to find NCV into delta T by NCP into delta T. So you have to find CP by CV, which is the inverse of gamma, and that is 5 by 7. Yes or no?
Yes.
Remember this. This question may just appear in your examination. So this quick one. Okay, so the other half will go in expanding the gas, changing the volume of the gas. That is known as work done. That is known as work done. So don't get worried if you see a question which has work done. This one, give me the answer fast so that I can move ahead in life. A monatomic gas expands at constant pressure on heating. Monatomic gas. The percentage of heat supplied that increases the internal energy. If you understand the internal energy, you don't have to understand even the next other one. You can get the answer straight away. What is the ratio? Yes, my dear friends. Do we have anything that looks like an answer? Or you need more time to think about it?
Option D, sir. 40 and 60%.
Take a deep breath. The first percentage should be of heat, of internal energy. So take a deep breath and now tell me the answer again. What percentage of energy is utilized to change the internal energy? Yes. Delta U by delta Q. NCV delta T divided by NCP delta T. 1 by gamma for a monatomic gas. 3 by 5, my dear friends. 60-40. Internal energy 60%. Work done is 40%. Not very impressed with your theatrics on this one. I hope that you have understood your mistake. Yes or no? No or yes?
Yes, sir.
What, sir? Anyway, sir, Let me see if you can give the answer for this one, sir. The value of Cp minus Cv is 1 hour for a gas in state A. And Cp minus Cv is equal to 1.06 hour in another state. If Pa and Pb denote the pressure and Ta and Tb denote the temperature in the two states, what is the correct relation? You have 2 minutes to go back and remember what is what. Cp minus Cv is equal to R. What does this mean? For which gas Cp minus Cv is equal to R? For which gas? We don't know the name of gas. It can be hydrogen, it can be oxygen, it can be chlorine, it can be ammonia, it can be CO2. How do I know? Huh? For which gas Cp minus Cv is R and remain constant like this? Does not change with temperature or does not depend on the process. Yes. For which gas? So they are infinite gases. Which gas you want? Which gas? Students are like cash vouchers. Sometimes the cash voucher may not work. There are gases known as ideal gases. Some gases exist which are known as ideal gases. These gases are ideal gases and Cp minus Cvs are only for an ideal gas, my dear friends. I've told you that. Probably I have not told you Cp minus Cvs are for an ideal gas. Cp minus Cvs are for an ideal gas. Then what is this gas? Huh? So it can be chlorine, it can be hydrogen. What do we know? Infinite number of gases are there. This gas is which gas? Huh? Non-ideal gas or real gas. The value of Cp minus Cv is 1 hour for a gas in state A, and in another state B, it becomes something else. If Pa and Pb denote the pressure and Ta and Tb denote the temperature, what is the relation? When does a gas behave ideally? That is the first thing that I told you in KTG. When does a gas behave ideally? We write everything that we don't remember. And the only thing that you have to remember is to forget the habit of forgetting things. We write everything, but we don't remember it. And what is the to go back so back. Here, my dear friends. And you would have written this. All real gases behave as ideal gas at high temperature and low pressure. If you write something, you remember it. Else you don't write it because there is no point of having 4 TBs of data in your memory, and when it comes, you can't even use a single byte of it. At high temperatures and low pressure. So temperature should be high and pressure should be low. And see, that thing is now applied here. And that is how you use things that you learn and apply it in questions when they come in real senses and when they come in your exam. Otherwise, we are all at sea. That is how you utilize your knowledge, beta. That is how you apply concept. At temperature, at state A, it is ideal. At state B, it is real. So at state A, pressure has to be low and temperature has to be high. And that is the answer. Which option is correct? Option C. Pressure should be low and temperature should be high at point A. Do we understand this or this has gone above our saying bye bye sir हो गया sir अब जाने देते हैं इसको.
We understood.
Remember this, any question from here can come appear in your exam all of a sudden. I did not intend to do so many questions, but I'm not feeling confident that I've covered every question, and I'm not confident that if I don't cover them, I don't think whether you will be able to do it or not. So the entire exercise will go in waste. I don't want to waste anything. Certain amount of an ideal gas is contained in a closed vessel. We had done a question where the lorry was moving. We had to find out the kinetic energy. This is somewhat different. Certain amount of an ideal gas is contained in a closed vessel. The vessel is moving with a constant velocity v. The molecular mass of the gas is m. If the vessel is stopped suddenly, what is the rise in the temperature of the gas? This is JEE advanced material. I would be very glad if you can give me the answer for this one. Your time starts now. And you have time to redeem yourself. Redemption. Students are like cash vouchers. They can redeem. So, what is going to happen here? The entire cylinder or the vessel is moving with a constant velocity. So, because of this velocity, it has the kinetic energy or the energy in the gas. Kinetic energy will be half into m into, let me not use small m, let me use capital M is used for molecular mass of the gas. Let me use m naught, where m naught is the total mass of the gas into v square. That is the total kinetic energy. Now when it suddenly stopped, this total energy will be converted into heat, and this heat will be utilized to increase the temperature of the gas. Now remember, this gas is in a closed vessel. Therefore the heat required will be at constant volume, which is N into CV into delta T, where delta T is the change in temperature. N is the number of moles. If I have to find out the number of moles, what will I do? I will divide the total mass of the gas by the molecular mass, which is given as m. CV of this gas, ideal gas, gamma is given. So CV of this gas is R upon gamma minus 1 into delta theta. This m naught and this m naught will get cancelled, and whatever remains will be your change in temperature. Your change in temperature would be m v square gamma minus 1 by 2r. That is the answer that we are looking at. Do you understand how this is done?
Yes,
The
sir.
total kinetic energy, that is the total energy, is get converted into heat, and that heat is required to raise the temperature of the gas. Which process? Because for different process, the heat required is different. The molar heat capacity is different. This is taking place in a closed vessel. Volume is same, so therefore it has to be NCV delta T. We know the value of CV, We can substitute it, get the answer, and stay happy. Do we understand this?
Yes, sir.
Pakka, sir?
Yes,
Kacha, sir? I'll give you 2 minutes to note it down. Then give me the answer for this question fatafat quickly so that I can move ahead and solve 2 or 3 questions from your previous year as well. Two moles of a diatomic gas and 1 mole of a monatomic gas, obviously they are not reacting with each other, are mixed. What is the ratio of specific heat of the mixture of the gas that is formed? You can do this, yes or no? I'll give you 2 minutes to give me the answer. So how are we supposed to find out the gamma of this mixture? Gamma of the mixture will be found by Cp of the mixture divided by Cv of the mixture. How will I find the Cp of the mixture? So gamma of the mixture, Cp of the mixture will be N1 Cp1 plus N2 Cp2 divided by N1 plus N2. Cv of the mixture is N1 Cv1 plus N2 Cv2 divided by N1 plus N2. N1 plus N2 will get cancelled, yes or no? Cp of the first one, 1 mole of monatomic gas, Cv is 5 by 3R plus 2 moles of diatomic gas, Cp is 7 by 5R divided by 1 into Cv of the monatomic gas is 3 by 2R. Oh, what I'm writing 5, 7 by 5 I'm writing. I'm in some other universe. 5 by 2, 7 by 2. 3 by 2 plus 2 into 5 by 2R. You have to just calculate it. What is the answer you are getting by calculation? The answer that is given to me is 19 by 3. Are you getting that answer? Yes or no? No, yes. You should have done this. Anyways. This one I need an answer quickly. Let's see who gives me the answer quickly for this one. I'll give you 2 minutes to give me the answer. 32 degrees Celsius is correct. Well done. See, students are like cash vouchers. Sometimes they may not work. That's not because the cash voucher is wrong. The person has put the wrong code. So heat gained by 1 is heat lost by another. N1 CV1 T1 plus. Do you remember that, na? Divided by the temperature N1 C1 plus N2 C2, you will get the answer. Yes or no?
Yes, sir.
So the temperature will be N1 CV1 T1 plus N2 CV2 T2 divided by N1 CV1 plus N2 CV2. Yes or no?
Yes, sir.
See? That question has given me a lot of confidence. This one, my dear friends. The specific heat, whenever you hear the term specific heat and you get a question, you must see smile because that is the simplest question. The specific heat Cp and Cv of diatomic molecules are given as 29 and 22. Another gas, diatomic, has a corresponding value. The value is given in joule per Kelvin per mole. 32 and 40, 21. If they are treated as ideal gases, then both the gases are ideal gases, remember. A has vibrational mode, but B has none. Both B and A have vibrational mode each. A has one vibrational mode and B has two. A is rigid, but B has a vibrational mode. Nah, how to do this? You have 2 minutes to show your talents. So let's not chill and let's do something else. Gamma is an ideal gas. So gamma is Cp by Cv, my dear friends. And this gamma is 1 plus 2 by F, my dear friends. All the formulas are already there with you. You just have to use them. From there, you will get the value of F. Diatomic gas, you know the value of F should be 5 without vibrational mode. If there is one vibrational mode, it will become more. Just have to find out the value of F from here. For the first case, 29 by 22 is equal to 1 plus 2 by F. From here, if you calculate the value of F, I think you get the value of F as 6.67 something, which is approximately equal to 7. So this gas A has one vibrational mode. What about the gas B, 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 B? 30 by 21 is equal to 1 plus 2 by F. If I find the value of F from here, my dear friends, F will be coming as 5. The original degrees of freedom. Therefore, the correct answer has to be option A without any doubt. Do we understand this, or this has gone above our heads saying bye bye, bye bye, bye bye, bye bye?
We understood, sir.
What we are not able to do it, sir? We have done so many questions, sir. That is why I am not getting confidence in your ability, man, sir. And that is why I had to do so many questions, sir. But again, I always believe that students are like cash vouchers. Sometimes the cash voucher may not work, not because the cash vouchers are wrong, because the code was put wrongly, and the time now comes to put the code rightly and set the records correctly and to redeem yourself. This is a question of redemption. A gas mixture, gas mixture. 3 moles of oxygen, diatomic gas. 5 moles of argon, monatomic gas. Considering only transitional and rotational modes, no vibrational, what is the total internal energy of the system? You have 2 minutes to show your talents and redeem yourself.
15 RT, sir. 15 RT.
15 RT. You see, that is the correct answer. Students are like cash vouchers. Just have to redeem them correctly. So the total internal energy of the system, U, will be NCV1 into T1 plus NCN2. Let me write N2, N1 and N2. CV2 into T2. Both are at the same temperature. Number of moles 3. CV is 5 by 2 R for this. Temperature is T. N2 5 moles of argon 3 by 2 R into T, and that is our answer 15 RT. Do we understand this? So this is gonna be saying bye bye. Bye bye. Bye bye. I'm going bye bye. Let's see who can do this one. Remember, KTG is one of the easier topics, and I always believe that it has a lot of potential of questions coming from here. And if you understand this chapter carefully, the questions are pretty damn simple. An HCl molecule has rotational, translational, and vibrational motions. The RMS velocity of HCl molecules in gaseous phase is V. M is its mass and Kb is the Boltzmann constant. Hey, what is the temperature? Hey, what type of question is this? You have 2 minutes to show your talents. Option B, sir, is absolutely correct, sir. It has 7 degrees of freedom. Yes or no? 3 translational, 2 rotational, and 2 vibrational. One vibrational mode. You understand this? Huh?
Sir.
So the average kinetic energy per molecule Vrms square will be 7 by 2 kT. Yes or no?
Yes.
We are talking about the total energy. Translational, rotational. We are not talking only about the translational. If it is the only translational, it was still 3 by 2 kT. We understand this? Yes or no? Huh?
Yes, sir.
Now we are getting good. Now I am getting some confidence. So more confidence. This one. Let's see who gives me this one. For a given gas at 1 atmospheric pressure, RMS speed of the molecules is 200 meter cube. 200 meter per second at 127 degrees Celsius at 2 atmospheric pressure and 227 degrees Celsius. What is the RMS speed? And you have 2 minutes to give me the answer. How are we supposed to do this? Huh?
Sir, VRMS is directly proportional to under root T, sir.
Yes, sir. So, sir.
So it doesn't depend upon pressure.
Yes, sir. So, answer, sir.
So answer is under root 4 by root, that is root 4 by root 5 into 200.
So the answer is VRMS is root over 3RT by M. M is
Okay.
name.
Okay, that is 100 root 5 meter square.
100 root 5 is correct. VRMS at temperature 2 divided by VRMS at temperature 1 is root over T2 by T1. Root over final temperature is 500 Kelvin. Yes or no? and initial temperature is 400 Kelvin. So it will be root over 5 by 2 multiplied by 200. The answer is 100 root 5, my dear friends. Do we understand this? Oh, this has gone above our head saying bye bye, I'm going, bye bye, I'm going, bye bye. Sir, हो गया, जाता हूँ मैं. Huh? See, one question comes from one topic in one session. The same question comes from the same topic in same session. All the questions that I'm doing is from very present years, and all of them are from the same JEE. A mixture. Whenever you hear mixture, you must get excited. A mixture of 2 moles of helium gas. Atomic mass is given as 4 mu, and 1 mole of argon gas. Atomic mass is given as 40 mu. Is kept at 300 Kelvin. What is the ratio of their RMS? Please. You have 2 minutes to give me the answer and redeem yourself. So you see, these are questions that come in JEE Main, and what questions we have done are way more complicated than this one. Yes, we are asking simple questions based on simple ratios. VRMS is root over 3RT by M. It does not depend on R. It does not depend on the number of moles. Number of molecules does not depend. So we can say RMS of helium divided by V of argon will be equal to root over mass of argon divided by mass of helium. They have also given you the masses. See, physics is so simple. So this will be under root of 10, and under root of 10 is very close to 3.16. Do we understand this, or this has gone above our head saying bye bye? Sir, I'm going bye bye. Sir, I'm going bye bye. The last question for today and last question in KTG is coming up. With this question, I think I have covered all questions that can possibly come in your exam. Even if any question comes, that would be plain luck. That would be plain luck. It's not possible for any other question to come from this chapter. 15-gram mass of nitrogen gas is enclosed in a vessel at 27 degrees Celsius. Amount of heat that has to be transferred to the gas so that the RMS velocity of molecule is doubled. You have 2 minutes to show your talent. How are we supposed to do this? The first hint is that the RMS velocity should be doubled. If the RMS velocity is doubled, what happens to the temperature?
It's 4 times.
It's 4 times. That's it. What is the initial temperature? Initial temperature is 300
300
Kelvin.
kelvins.
So it becomes 4 times. Yes or no? We have to find out the heat required. Yes or no?
Yes, sir.
This is at constant volume because the volume is constant.
Yes, sir.
N number of moles is 15 divided by 28. Yes or no?
Yes, sir.
CV is 5 by 2R. Yes or no?
Yes, sir.
R is 8.3. Yes or no?
Yes, sir.
Into delta T is 900. Yes or no? From this, they have given the answer as 10,000 joules. Then 1000 joules is the answer they have given. I don't know the calculation. I hope you can do that. Yes or no? No, yes.
Sir, I have done the same, but answer is not matching.
Okay, so you can just do the calculation I think if I do a approximate calculation, 9 ones are 9 and 9 threes are 27, 3 5. So 25 into 8. 25 into 8 is how much? 25 into 8 is 200.
200.
200 divided by 2 is 100. The answer is 10. I'm an old fellow, 43 years old. I can do an approximate calculation just like this, and when I don't know how to calculate, how can you not calculate it? We need an approximate answer, beta. I don't know what you have got. And I can't help you with calculations because that is not my forte. I told you right now in front of your eyes how I would have calculated. This is how I would have calculated. So I have finished this class here on this revolutionary note that we are done and we have to work on your calculation. I can't help you there. The only way you can improve your calculation is by calculating. Keep on calculating. Make formulas like this, calculate, get the answer, stay happy. The next class we'll start with thermodynamics. Thermodynamic processes is what we are going to start with. Probably in 2 classes or 3 classes we should be able to do them, and 3 more classes we should be able to complete your heat transfer. What day is today? Today is Monday, so probably by Sunday we should be able to wind up your thermodynamics completely by all measures. That is what I hope. And let's see, we can do this so that from the next Monday, 15th or 16th, we should be able to start your electrodynamics, electrostatics. Take care. God bless all of you. Anyone has any doubt?
No, sir.
Okay. Then keep solving. You have got the sheets. Please solve the sheets. This many questions, even this many questions are more than enough. I'm not even relying on sheets now. I'm more thinking, better do the question in class than leave it for the homework. That's why. Okay then. Take care. Bye bye.
Thank you, sir. Have a good day.
Bye bye.